So this is what people are going to see when they visit YouTube. And what will happen here is I will post this immediately after class there so that y'all can watch it again and again and again. We have single moms, single dads. We have people in caregiving positions and working full-time nights. And, you know, society is all just turned upside down. So the most important thing is you don't have to be here at 8 o'clock in the morning. You just got to be able to watch this video so that you guys can do the assignments and all that kind of stuff. What has been posted on Blackboard? You have the course outline, okay, which we'll go over. That's from Georgian. That just details all of the outline of what you're expected or what there's objectives and outcomes. But what I'm going to show you guys here is I'll do a screenshot. Okay, so this is what you really want to know. All right, and so I'll be in here every Wednesday at 8 o'clock. Okay, and there's the WebEx link there. I'll post it 2 or 3 times a week anyway. All right, contact information. Okay, ian.coates@georgiancollege.ca. All right, and this is what you want to see right here. Okay, it's a 13-week semester. All right, and what we're going to be doing here is there's nothing going on there this week as far as assignments or anything. Okay, so we're going to go through this week. We should be here an hour. Well, I might do a little bit of a blurb there on the introduction to the course, but other than that, you know, it should be about an hour, hour and a half, hour, 20 minutes, somewhere in there. Next weekend there, we move on to 1.2, and I'll open up assignment 1, okay? And things, as with this shortened semester, things kind of happen quickly. So don't let this pot boil over. All of these assignments, the quizzes, the tests, everything is completely doable. And I've kind of designed the course where if you don't have the textbook, it's all right. You should be okay. If you have the textbook, you're going to do great. All right. And you guys are going to do great anyway. As I said there before, this course is not designed to, you know, it should be there and it should be here to boost marks. Okay. So that's where we're at right now. And we're just taking you guys on an introduction to statistics. And some say statistics isn't even a real thing, you know, but the whole thing with statistics is it's a scientific process to take mashed potatoes and organize them into, you know, small French fries, big French fries, large French fries, and, you know, and so that you can get some type of an idea of what's going on. And because you want to take chaos, you want to take unorganized data and organize it into a fashion that can be utilized to further the advent of science. That's what this all is. And where you guys are going here, I don't care if you're going to be vet techs, I don't care if you're going to be nurses, you're going to be paramedics, firefighters, you guys are going to be reading these journal type articles about statistics for the rest of your life. And that's what this is, all right? So this is important course. A lot of it there it's a new language. But again, it's not there to really take away from the other courses, okay? So first test, there are 3 tests, and there's no classes during those weeks. So you've got test 1, which is week 4. You've got test 2, which is week 9, and test 3, which is week 13. Now, they're designed to be non-cumulative, but that's an impossibility when you're talking with mathematics and statistics, okay? Where, you know, in mathematics, you got to learn to crawl before you can walk, and then you got to learn to walk before you can run, right? So everything, basically your knapsack will get bigger and bigger and bigger as the weeks go on. So, but again, the tests aren't so bad. We'll tell you guys all about those as things come. But your first assignment is out next week. All right. And then the week after, there'll be a quiz quizzes will be open, okay, and you'll have some time to do those, and tests. I'm thinking there that these tests there that we'll have a 3-hour window, and that's how she'll go. But we'll work on all these, okay? And there's the course in a nutshell. Please print that off, have it somewhere, because these condensed courses there where we lose a week or two. I don't want any mishaps. And if you have, the most important thing basically is if there's any issues, just email me. We'll set up a WebEx. We'll talk about it. We get through it. Okay. If there's any issues there that happen, emergencies, I don't really need to know details, but I need to know kind of what's happening. And if there's, I tell you, I'll be your biggest advocate. Okay. I'm not here to take marks away from you. I'm here to give marks. So let me know if there's any issues going on. Let me know if you possibly foresee something going on 6 weeks from now. Like, okay, so I just saw a chat come up. If there's if you do have any questions, ask away. If not, I'll kind of let the questions go because I don't have it up on my screen right now. Okay, but if you guys have a question, turn your mic on and just say hi and good morning, and let's ask your question. But you'll see here that like we'll finish week 2 next week, and then afterwards I'll open assignment 1. I think you'll have 2 weeks to do it, and you guys are probably old hat about uploading things there into Blackboard and all that kind of stuff. So if there's any issues about how you guys should upload or anything like that, just shoot me an email. We'll talk it out and we'll get you all through. Okay? How you guys doing? Any questions?
Hi, morning.
Hi, good morning. Who am I speaking to?
This is Gaganveer.
Hi.
Just a quick question here. Like, the assignments will be due before class or before midnight, like 11:59?
I kind of that's a good question. I kind of like things due, like you'll see there when we go through the chapters there's a lots of questions, practice questions there for you guys to do, and please don't do them all, but do some of them so that you guys get an idea of what's going on. You'll see there that the quiz is before the test because I want you guys to get a feel of what the test will be like. The assignment as well. I want you, everything is designed to practice for the test. So I don't know, it'll probably be due there before the test, but everything will be outlined there, and there'll be instructions on the assignment, so it'll all be all right. Okay, good question. Sorry if I didn't really answer it, but we'll get there. We'll get there.
Sure. Thank you.
No, it's all good. Good questions. How are we doing? We're all good?
Hey, good morning.
Hello, who am I speaking to?
This is Megan.
Hi, Megan.
Hey, I have a question. Do you guys have practice tests?
If you guys have access there to the book, you see the book, as with all textbooks, you know what I mean? It's like this big, and 85% of it is mashed potatoes. There's only really 15% of content that we'll be utilizing from the book. So if you guys have online access, I think that Veretta has some stuff there. But you guys will. I have questions and answers for every single week. So the questions there, I'll show you guys right now.
I have one more question.
Yeah.
We're done.
Go ahead.
So with our rough work, can we hand it in for any extra marks or no?
I don't know.
When we're doing tests.
The syllabus is already kind of made. There's really no room for extra marks. But in all fairness, awesome question. I don't think you guys will need it for this course.
Okay, cool.
Focus on this course, but the bio there, that one there is going to be hectic. Thank you, Megan, for your question. The chemistry there, the first half is hectic. Okay, so this course here, I don't mean to diss this course, but this one here should be pretty good. Okay, and wait until we get to the assignment. You guys will like the assignment. It's an interesting case study. Okay, so how this course is going to work here, we've got 3 tests, 20% each at 60. Okay, we've got quiz 1, 2, 3. They precede each test, just to give you an idea. They're 5% each. Assignment 1 and 2, and then there's also a case study that we use there. And that's how the course will work. That's where it is. You know, I was thinking about giving you guys quizzes every week, but you guys are going to have other fish to fry there this semester. So that's what's going on there. It's not too bad of a course. Okay. How are we doing? Any more questions? What do we got? Want you guys to have fun, and please keep in contact with me. If something doesn't make sense, I've made this there. I've taught this course there a couple times. Please, rule number 1, if you're doing a question, a homework question, and you're not getting the answer that's in the back, or you're not getting the answer there that I gave you, do it twice. And if you still don't get the same answer, email me and say, Ian, question 34 on page 189 is irritating me. I've done it twice. Could you verify? Could you help? You know, and that's how we do it. I've had students there that have gone all night trying to get this question number 34 on page 189 because, you know what I mean? They're hungry. You guys are hungry. You guys want this. And as it turns out, the answer in the back of the book was wrong. Okay, so do not waste your time. Your time is very valuable. You guys have, 6 courses now? You guys are running around like crazy people. And you know what? You're younger. You can do it. You're doing great. You got 13 weeks, and now you're into a program there that you dreamed of being in. Okay, so if a question isn't working out, do it twice, and then email me. Okay, don't waste your time. Waste mine. All right. If you guys got nothing else, I'm going to start it all up. But I just wanted to show you guys there that what everything is in your folder there this week and every week. I'm enormously huge on giving questions and answers. Y'all paid your big bucks to be here. Y'all are adults. What, am I going to hold the answers from you? You know? I'm giving you test questions every single week. Everything I show you is a test question. All I'm going to do is change the numbers or the scenario. Instead of Alice picking apples, I'm going to say Tom is picking grapes. Or, you know, and then the question will unfold. So please try these questions. The PowerPoint and the questions are pretty contained. So if you don't have the book, it's okay. Everything is here. And you'll see here there that these aren't for marks. These are just for your own. And each question here is 4 questions. It's not multiple choice. All right? And it's asking you there to identify which sampling methods would be most appropriate for the following. So you got 1, 2, 3, 4, and you've got 10 of these. And all the answers. And this is actually page 16 and 17 in your book. So if you already have your textbook, then these are the answers right here. So that's how this course will go. I'm very front forward about giving answers and questions and leeway. So you guys just keep on top of this, and y'all will just be just fine. I don't anticipate any issues. But if you anticipate issues, let me know soon, okay? Because now I can make accommodations. I've had people come to me there the night before the exam and say this, and I'll do everything I can. But the closer I get to a test date, the tighter my wrists are locked together. So just keep me in the loop, and we'll get through this. How we doing? We okay? Everyone got their coffee? Let's go. And again, if you got a jet, if you got to go, your kids need chocolate milk or something, you know what I mean? Trust me, I've been teaching online here for the past 18 months since the pandemic started, and at the first couple weeks there, trying to keep my kids out. But, you know, you just can't stop a tidal wave. So if they come in, they come in. It's all good. We'll have a meet and greet. But welcome to Math 1031. Okay. Attendance is not mandatory. But what is mandatory is that you please check YouTube. Like right after here, I'll upload it to YouTube, and I'll send an announcement out with a link. Okay, so that you guys can watch this on your own time. The course is not bad. Okay, it's a new language. It'll seem a little different. All right, but then once we get into it, there will be things that seem very familiar, like mean, median, and mode. We spend a week or two on that. So it's not too bad, all right? We've gone into quizzes and assignments. We'll talk more about those as they come up there next week. We'll do the PowerPoint there, and then there's the homework questions, which I've already showed you, all right? So if the whole thing, if you have any questions, email me. I check my emails like 10 times a day. Usually I take Friday afternoon off around 2, and I don't show up again until Sunday 2 o'clock. All right, so I take my 2 days there with my family. But other than that, I'm checking my emails all the time. So just because I'm not there with you doesn't mean I'm not there with you. We are all in here together. Okay, so here we go. Overview of data, introduction to statistics. So first we're going to talk about data, and then we'll what is data or datum, and then we'll move from there. Okay, so here we go. Welcome to statistics. Statistics is a branch of mathematics and science that helps researchers to develop a set of procedures to collect, organize, present, analyze, and interpret data. So as I said, you're taking mashed potatoes, you're taking completely unorganized information, and you are stratifying it, organizing it, and you know, I don't know if you guys know that you can skew data, you can change data to suit your own needs. So if somebody takes this unorganized data and makes this, oh, you see what's happening here? As we go along, the price is increasing. You see, what we're looking for is trends. Is there a pattern? And this is completely scientific data. But also, data can be manipulated. So if you're on this side of the fence, and you want your data to look like this, well, okay, you can do that. But if you're on this side of the fence, you can actually manipulate your data to suit your needs. So as with truth, is there actually really a truth? Maybe not. Maybe there is only perception. Interesting stuff. But you can see here that there's lots of uses in statistics and health sciences. Okay, learn about overall health trends. Honestly, if you've been watching the news, reading the papers for the past year and a half about the pandemic, there's statistics on morbidity rate, mortality rates, infectious rates, death rates, all these different statistics there that are being thrown at you. And yeah, it'd be interesting to see if we can apply any of this data. And when you watch the news, maybe you might hear some familiar terminology. Okay? To weigh the potential risks and benefits of a particular treatment, like I think there with the AstraZeneca. That's the vaccine there that's been causing the blood clots. And there this semester, you're going to learn about blood clots. They're in bio and how dangerous they really are. Okay? And I guess the statistics say that it's about 1 in every 55,000 Canadians or people around the world in Europe and all this that take AstraZeneca, 1 in 55,000 develop serious blood clots. So there's a statistic. And what they've done is they've taken raw data and amalgamated it and cleaned it all up and came up with that. Now that's a pretty astounding number. 1 in 55,000 people will or are suffering from these deadly blood clots because, okay, and you know, so you, from the mashed potatoes, from the disorganized, chaotic data, we can pull something out. And if you pull something out, and you now make a statement, you have to be able to back it up scientifically and mathematically. And because 1 in 55,000 people are suffering deadly blood clots because of this vaccine, that's a pretty serious thing to say. So it's got to be backed up scientifically. So that's where we're at right now, is we are in the process of developing your scientific critical mind. Okay? Costs associated there with hospitals and all that. Like right now, everything is just getting blown out of the water as far as budget goes. So there's the administration side where they deal with the facilities of the hospital, but then there is also the treatment side as well. So there's all different sides here. Okay. Descriptive statistics as opposed to inferential. So there's statistics, the whole umbrella, but then it can be broken down into two okay? And descriptive statistics, basically describing, okay, what's going on. Deals with the organization, presenting, and summarizing of raw data, okay? And the whole point is, are we going to get something meaningful out of this that I can utilize? So these are what descriptive statistics are. And then there is inferential statistics, which deals with the analysis of a sample drawn from a larger population to develop meaningful conclusions about the population. So descriptive statistics, we've got the data, and now we're just kind of reorganizing it into a way that's meaningful. But then there's inferential statistics, where like it costs money to do a survey. Whether it's a phone survey, a mail-in survey, an email survey, all these kinds of things. It costs money, right? And if we really wanted to know what was going on for a particular aspect there across Canada, we could, in theory, go house to house and ask everybody in Canada. So we've got 35 or 36 million people there. We'll go to the 2 million homes across Canada, and we'll ask everybody, but that's going to be too much money, too much time. How many people are going to be involved? You know, gas is $1.30 a liter. Are we really going to, so all these kinds of things. But instead, why don't we just take a sample population of that 35 million, 36 million? Let's do a sample population of 50,000 people. Can we, when we get this information from the 50,000 people, can we actually take that and, is it statistically valid as a true representation of the Canadian population as a whole? Well, sometimes it is. Sometimes it's a crapshoot. We'll show you. All right. So today is just an introduction. I'm just going to throw a whack load of terminologies at the wall, and hopefully some of it will stick. And then you'll go back, you'll have a look at the textbook, you'll have a look at the questions, and then it should be all right, okay? So, good stuff here. Important terms. We're going to talk about population, sample, an attribute, variable, parameter, and statistic, all right? And some of these are going to be wordy, and I'm not going to try and, you guys can read them afterwards or whatever, but I'll paraphrase because I'm trying not to bore you. Probably pretty boring. All right. Population refers to a set of all possible individuals. So, population of Canada, all students enrolled in a post-secondary health science program in Canada. Here is your population. That's what we want to target. We want to extract information from there. A sample refers to a subset. So instead of looking at or asking all the people in this population, we're just going to take a representative sample. Now, how you do that, there are different ways of doing this, okay, and for different purposes. All right, but we'll get in there. So a sample is just a representation of that population. An attribute, okay, refers to the characteristic of the data that you're looking for. Observed, measurable, categorized. So age, income, gender, blood type. these kinds of things. It's the idea that you're focusing on or measuring, okay, that kind of thing. Variable represents the value of an attribute. So going back to, the attribute is the idea. The variable is the representation of the idea in the real world. So age, 20 years of age. Income, 40,000. Female, male, okay, blood type, all these kinds of things here. So these two are kind of linked, okay, and you'll see there that the variable is the idea that we can manipulate, change, because if A plus B is equal to C, well, what if and A and B are these attributes and C is some other attribute? Well, what if I change C and I go A plus B minus is equal, what do we get? See, I tweaked one of the variables. What kind of outcome do we get? Is it an expected outcome? Is it completely unexpected? Is it scientifically rational? Welcome to science. That is an experiment where A plus B produces C, but now A plus B minus, what does that produce? C minus, C plus, does it produce? And that's the whole thing. And that's what we're going to kind of deal with here. Our case study that we do it's laughable. I'll tell you all about it later. But the statistics behind it are awesome. And the ability there to interpret numbers, it's almost like the Matrix, I don't know if you guys you get all these, and how can you make sense of it all? And watch and see. It's quite amazing, all right, where you guys will be in about 9 or 10 weeks. Parameter refers to a value that summarizes a certain variable for an entire population. Aha, the mean. So it's the average, right? The mean average of a class was 72. So that means that the average, okay, 50% of the class got a mark above 70, 50% of the class got a mark below 70, so 70 is the average. And that's going to be a central focus there towards the end of the course. Standard deviation, how spread is the data? Is they take a sample, I want to know how many apples you eat a year. So we go around and we ask everybody, how many apples do you eat a year? Okay, and if everyone's eating 15 apples a year, well, it's going to look kind of strange, but everyone is going to eat different numbers of apples. Some people don't eat any apples a year. So you're going to have people with 0. You're going to have people who are apple crazy and they eat 10 apples a day. So, and how spread is the data? We'll get in there because the dispersion of data is very important. It also tells you something about a population. Okay? And what I mean by population, you can have different populations within a population. Like maybe like here in Simcoe County, people vote conservative. That's what it is. But if you go to the district of Sudbury up north, generally people vote NDP. And then if you go to another county, people will be voting Liberal. Now, why is that? Well, within the country of Canada, we have provinces and counties and all, and people tend to congregate with other people generally of the same mind frame. And it's interesting. We'll get into all these different kinds of things. It's going to be a lot of fun. It's more of a societal project than a math course. The math is kind of subsidiary. Yes, there's math and you got to have a calculator and all this, but here we're going to be talking about societal issues all day long in this course. And this course is actually kind of interesting, okay, in that respect. Statistics refers to a value that summarizes a certain variable or a sample. So we're going to get into all these kinds of things here. What is a population parameter? Okay, so you have a look here. A researcher is interested in determining the average annual income of family physicians in the city of Toronto. So average income for doctors in Toronto. She randomly selects a sample of 50 doctors in Toronto and uses the data gathered to estimate the average annual income for all family doctors in Toronto. So here's your population. Okay, and what is the population parameter of interest? The average annual income for all family physicians. So that's what we're talking about here. And what is the sample statistic? 50 families selected. So I will tell you, the hardest part about this course is pulling relevant information out of the question. You look at this question here, it's 1, 2, 3, 4 lines long. There's a lot of information in here that is not necessary. And students sometimes have a tough time pulling out what's important. All right. And I want you guys to practice that skill. All right. Because I don't want the English to be the problem. All right. And it doesn't matter if English is your first language or English is your second language. I taught ESL overseas for 15 years. All right. So I know all about ESL and I know all about the complexities of English and how English it's a strange language. Like, why is there a K in the word knee? Why is there a K in the word knife? Because they actually come from Scandinavian countries. And English is not an easy language, so I don't want you guys to be afraid of these. Pull out what's important, practice what's important, practice pulling out the important information. Okay. Inferential statistics is important to draw a sample from the population, right? We don't want to spend millions of dollars asking everybody in Canada what their opinion is on a particular topic. We're only going to do a representation. But the problem is your sample biased? Okay? Does it suit your own needs? Like if we take a sample, we ask 1,000 people in Barrie what their opinion is on a certain situation. Can we really scientifically infer that once we ask these people their opinion and we collect the data, can we push this and say this is how Canada feels about this particular issue? Well, you've got to be careful because you have populations within populations, whether they're ethnic populations or not. And you've got age populations. You go to one of my favorite places in the whole planet is Elliott Lake. And beautiful. You ever get a chance. It's in the middle of nowhere up in Ontario. But, its demographics have changed over the past 30 years. There was a uranium mine there. They shut it all down. Houses were $10,000, $15,000, but then they reoriented themselves into a retirement community now. So the demographics have changed. The average age has gone up. And that's how these goes. It's populations can change, demographics can change. Is there a trend? What is happening now is basically the most important question that all statistics is trying to figure out. What is happening here? Okay. Taking samples. There's a whack load of ways there to take samples. Okay, and here are 6 of them right here. All right. Researchers can use these in order to ensure a sufficient degree of randomness. That's what this is. We want random. We don't want any type of structure as far as choosing, because then that could be accused of biased behavior. And biased has no place. Opinion has no place in science. We're looking for fact. So let's have a look here. So the truest form of randomization, okay, is the simple random sample. And you see there, you got a couple names in a hat. You draw names. And there's no way of knowing whose name it's just completely random, right? So using an example there, using a computerized random number generator to select values there for this sample. So that's what we call a simple random sample, where everybody has an equal chance. Okay? Here we have a stratified random sample. Stratification just means different layers. Like from an archaeological point of view, you dig down into the earth and you look at the side of the earth there that you've just dug into, and you'll have a topsoil layer. You may have a sandy layer. You may have a clay layer. That's stratified. Okay? So there's something going on here besides just a population. And you'll see what's going on here. And certain populations, a particular attribute of the data, like gender, will potentially strongly impact the value of the variable being analyzed. Okay? And so it may be considered desirable to have a sample that reflects the proportionate diversity of the population. So you see here, depending upon the population itself, here we've got male and female, you know what I mean? It could be other parameters as well. And like if we take just a pure random sample, in theory, we could get 90% blue dots and 10% green dots. But is that what this population is? Is it 90% blue and 10% green? No, it looks pretty 50-50 to me. So our sample better be representative of this. And that's what we've got here. And because we want to make sure that this group's opinion is important. This group's opinion is important. And both of them need to be represented proportionally. Okay? So that's that one there. Okay, so just continuing here. Here, step 1, identify the particular attribute to be isolated. Divide or stratify the population. And then you randomly sample from each. So that's what's gone on here, right? Here's your population. You identify what you want. You're looking at your attribute. Okay, separate them, stratify them into their respective groups that you want represented proportionally, and then you randomly sample from those two different groups. So it's called a stratified random sample. And I'm sorry this can't be that interesting at 8 o'clock in the morning, but all this information here, if you go to the questions there at the end, everything will make sense. And you're going to do some questions. Don't do them all. I think there's 40 questions there. Don't do them all. Do enough there till you feel comfortable that you can tackle all these, all right? Systematic sample. It is possible to achieve a randomized result without actually using randomization. Interesting, eh? This is called a systematic sample approach, okay? Where you create a numbered list of all elements in the population in any order, and you divide the size of the population by the size of the sample, and you get what's called an interval value, okay? And this interval value is K. You round K down, and you'll see here, to select a systematic sample of 30 from a population of 1,000, and you see here, we use this formula, and now we need 33 constituents. Okay, we'll show you this there. Let's have a look. So the whole idea of doing this, we randomly select a starting value between 1 and K and choose the elements of the population that correspond with that value. Add K to the starting value and choose the element that corresponds with the value. What does all this mean here? The whole idea is then we randomly select a value between 1 and 33 for a starting point. So what we're talking about here is we're trying to find a random approach using mathematics. And then we randomly select a value between 1 and 33 for a starting point. So example 27. So then we select every 33rd element in the population. So hold on here. Let's go back. We want to do a random sample, but we want a systematic approach to this. So we use this formula here, K, okay, and we're looking for, okay, we've got a sample of 30 from a population of 1,000. This number K here is going to determine who is going to get selected in the sample, okay? So if you'll have a look here, person 27, we just started any number between 1 and 33. 33 came from this value. Easy peasy. Take your population, divide it by the number of people you're looking for. Okay? And then you choose a number between 1 and that K value. Randomly. You could choose 5, 8, 13. Here we chose 27. Okay? So now what you do is you start at person 27 and then you go to person, you add 33 to it, 60, 93, 1, and these are the people that you are going to choose and ask about. That's all this is. Sorry if it didn't, these slides are kind of sketchy anyway, but this is what I want you guys to know here. This is a random way to a systematic system. So using K, you find a value, and this value is going to be 33 apart from this guy. So here you've got 27. The next person you will choose is 60. The next person you will choose is 93. That's what this one's called, a systematic sampling. And you'll see here that that's what we're doing here. Okay, from the population, you're choosing people using the K number. Try 1 or 2 of these there in the back and you'll it should be okay. That's all this is. It's a simple formula K. Divide your population there divided by the number of people you want to sample. And you get a K value, and the K value, you'll choose people using that K value. Cluster sampling. In some populations, it is very convenient to break the population up into clusters. Different neighborhoods. What's going on in these neighborhoods? Okay, so you're selecting a sample requires randomly selecting a sufficient number of these clusters and then sampling every element of these clusters. Okay, so there's another one there. You have multi-stage random sampling. When a population is very large, it may be first necessary to narrow down the population into smaller groups. So you see here we've got our population. Here we've got strata. Okay, we've stratified these guys. And then sometimes these different layers, they need to be subdivided again. Maybe what's going on in different neighborhoods. And you know what I mean? It's the whole idea of a population within a population within a population within a population. So if you want to do a study with this population on a given topic, but then you want to do the same, you want to look at the same idea using a population within that, you might get completely different results because these people, maybe they're thinking completely different than the bigger group as a whole. So that's how these ones go here. And it's just interesting. You're going to see data, the same data from two different, like if the data was a coin and you're looking at the coin from this side, wow, that's kind of interesting. But then you turn around and you look at the same data from the other side, wow, it looks completely different. So we'll get in there. Multi-stage random sampling. When a population is very large, it may be first necessary to narrow down. We just did that one there. And now we're moving into here, and it's the same thing. You're just breaking things down. Communities are first selected according to a stratified sample, ethnic or age or any type of however it works there. Specific blocks within those neighborhoods are randomly selected from stratified populations. So it's all random. And then all residents living on those blocks are sampled. All right, so the randomness is here. You'll see there that for all of these, there is some element of random. There has to be, because if it wasn't, it would be biased data. Convenience sampling. Aha, I like this one. Convenience sampling is sometimes used to collect a sample by selecting elements of the population who are readily available and willing to participate. The worst thing you want when you're doing a study is to have a participant who doesn't want to be there. Okay? So this is a cost-effective method because you can just pay people to get these things done, but it does not generally produce random samples and therefore can be very biased. Okay? All right? Sometimes to the point where the sample is useless. You can't even use this data because if you're only getting people who want to be in your study, well, okay, maybe you're paying them $1,000 each to be in your study. Hey, I'll be in your study. I'll do whatever you want me to do. I'll take my $1,000. Well, that's not scientific. That's ease, and there are other that can be a dangerous thing because you could spend $100,000 on a study, and it's no good. Okay. Like here, a professor wishes to know what students think of the cafeteria food on campus, so she distributes a survey to students in the cafeteria during lunchtime, asking them to rank cafeteria from 1, which is poor, to 5, which is good. You know, we call that a Likert scale, right? Where it's 1 with a unhappy face, 5 with a very happy face, and you know, it's kind of a gradient scale. We'll talk about that there later. Okay, based on the variety of different criteria. So you look at this example here. I don't know if you guys, there are some issues here. This professor is only asking students what they think of the cafeteria during lunchtime and in the cafeteria. Well, you got to think about that. The students who are in the cafeteria at lunchtime are probably eating. So they're okay with the food. Right? But what if, what about all the other students who don't eat on campus? They go off campus to eat. Where are they? Why aren't they here? What's going on? Their opinion matters to my scientific research. Okay, so it's easy. You just have to show up at the cafeteria at lunchtime, give out your surveys, wait 20 minutes, everyone hands them in. Whew, I just did a scientific study. Well, you better be careful, okay? Because it might be skewed to a direction there that you are not anticipating, all right? Which sample method is used? Have a look. That's all the questions are at the back there that I've given you the questions and answers to give you a scenario. What kind of sample would you use? And I don't want you guys to beat your heads too hard on this. Have some fun with these there at the end of the after doing the PowerPoint, and some of them there you'll just go, okay, I can kind of see it. But most of them there, anything on a test, anything on a quiz, there's only one answer, and everything will be cool in the gang. So you look here. A teacher is interested in estimating the proportion of students who bring a packed lunch to school. A list of names of all 400 students in the school is available. 40 students are randomly selected from the list using a random number generator. What's happening here? Simple random. Simple random sampling is used. Okay? And you guys can have a look at these there. But I don't want to keep you guys here forever. But we'll try one more here. A school board wants to study the effectiveness. Whoa. What happened there? A school board wants to study the effectiveness of team teaching. 2 teachers in the classroom, right? First, school districts are selected according to a stratified sample. Stratified, right? We've broken it up somehow. We've taken a population and separated it somehow, okay? So school districts are selected according to a stratified sample based on demographic factors. Finally, specific schools clusters within those districts are selected randomly from the stratified population, and all teachers in those schools are sampled. Well, you just take, and you have to think, these tests and quizzes and assignments, they're all open book. You know, oops, did I just say that? Oh, can't revert. I can't delete this. Everything's open book. So when you guys have a test or a quiz or something there, it's kind of timed. Like your assignments there, you'll have 2-3 weeks to do and all that. That's okay. But your tests and quizzes there, you know, you're going to have everything around you anyway. You're going to have all your PowerPoints open. You're going to look at this. And okay, that's multi-stage. So that's what we're talking about there. You don't really have to memorize everything. You just need to know where to find it in a given period of time for a testing situation. Okay? When a researcher desires to know the value of a particular variable, they use a study. There are 3 different kinds of studies. There's an experimental study, there's an observational study, and surveys and census. Now you think experimental studies, okay, where you have A plus B is this. Well, if I change one of these things, what's my anticipated outcome? What is my hypothesis? We'll get into hypothesis, okay? What do you think is going to happen? And in science, there is no, Dr. Jones was wrong. No, there is no right and wrong in science. There is only truth. So, you have, okay, my hat. Okay, now I'm going to drop my hat. I wonder what's going to happen. I think, well, you know, maybe it'll go up. Maybe it'll go down. I think it'll go up. Okay, let's conduct our experiment. Oh, rats, it went down. I was wrong. No, you weren't. That hat went down. Now, why did it go down? And you see, every answer leads to another question. And that is science. And there is no stop to science. Okay? So there's no right or wrong answer. It's all interpretation. What happened? Explain to me what happened. Observational studies, where you are not involved in the experiment. You are just observing, whether it's child behavior, okay, squirrel behavior, you know what I mean, you're some type of behavior, psychological, you know what I mean, you're just observing and taking notes, all right? Then we have surveys and census, all right, where we send out a survey and people provide their answers and then we take that, okay? So let's get in here. Experimental, we've kind of talked it all, right, involving manipulation of a variable to determine the impact on another variable. Okay? These trees here, they like this soil and this sun and this temperature and this water control, this amount of water. Well, what happens if I decrease the amount of water by 50%? What happens if I change the soil? What happens if I lower the amount of sunlight that these trees get during the day? These are all variables that we can manipulate to see what would happen, okay? And big pharma, big company, they're doing these types of tests all the time to determine what kind of better product there that they can produce, okay? These are conducted by taking a sample of the population being studied and randomly dividing it into an experimental group and a control group, right? Like the whole idea there that, does this vitamin pill work? Well, okay, we're going to choose 100 people at random. We're going to separate them up. We've got both populations here are pretty representative of each other. They look pretty good. All right. Group A, y'all are going to get the pill. Group B, y'all are going to get a placebo, which is just a pill. Looks exactly like this one, but it's probably just sugar and cornstarch. Because the mind can play, the mind and the body, there is a link. And people will say there that this pill changed my life. Well, that's great, but there was nothing in it. It was just sugar. It was just a sugar pill. And you see, it's called the placebo effect, where people think that they're getting the cure so that they get better on their own. Interesting stuff, eh? So, experimental studies here. It is important that every element in the sample be as similar as possible and that all possible variables are at least tried to be controlled. Like the amount of variables that can impact a particular study, it might take multiple studies to eliminate all of these other variables to really see what's going on. Because ultimately, what we're looking for is we will observe the effect. We changed this, and this happened. Now, that's what we saw, that's what we observed. But what we saw happen, was it because I changed this before the experiment? That's the whole ball game right there. I changed this, I did this, the cause, the effect. Is the cause really the cause? And that's the whole idea of trying to eliminate confounding variables. Okay? The independent variable is what I changed. Write that down. That's a good one. You'll see that again. Promise. So the independent variable is what I, as the experimenter, altered. The dependent variable is the outcome. That's what we saw. So again, independent variable is what I altered. The dependent variable is what happened. Now, the whole idea, did I change the independent variable and we got this outcome? What I did it cause that? Or is there something else in play that did that? So then that's called a confounding variable. Those are 3 terms there. Those are good ones. Observational studies. You know what I mean? Jane Foster went to the Congo there and observed the great apes. The beautiful creatures, man. Beautiful. So intelligent. And love them. Never made it into that part of Africa. Wanted to. Stuck to the north and the very south and the sides there, Kilimanjaro. But the whole idea of just observing and watching and recording. Benefits, easy to conduct. You're not involved in the experiment. You actually protect yourself, you protect the participants from even knowing you're there. So they're just acting normally. If you show up and say, hey, how's it going? I'm just going to watch you for a couple days. Your participants are going to be going, no, you're not. Get out of here. I don't want you here. And you see their behavior is going to be altered. So it's a no good study. So you're out of it. Drawbacks, it's easy. The benefits there are the easy. Drawbacks, results are typically less scientific because it's opinionated. Yeah, you can record this, and you can watch behavior. All right. But it should be recorded in a fashion that everybody can, scientifically kind of make an opinion on this here. Observing the effects on babies of mothers who smoke during pregnancy. Okay, so you know what I mean. You look at this study here, mothers who smoked during pregnancy. You can go prenatal and postnatal. You can observe the development of the fetus in utero, and then after the child is born, we can monitor the effects of the child's growth, development, all these kinds of things postnatal, and you can. It's good. It is good. Surveys, Canadian Census, those are out now. Oh, I don't think I've done mine yet. I might be in trouble. The Canadian Census there, it details, this is put on by the federal government there, just keep track of everybody, how many people are living where. It's all important stuff there, based for schools and hospitals, these kinds of things. If we have a population that wasn't there 2 years ago, but now they're here and they don't have medical care or a school in there, well, we need to get stuff. We need to get infrastructure in there. So that's surveys. Interesting. Depending on the amount and where you get them, they could be statistically good or statistically bad. Okay. We've got here positives here. It's good for obtaining basic demographic information. Okay, learning about opinions of different people and different neighborhoods, because neighborhoods think alike. They do. All right. Even cities tend to think alike. All right, and yeah, huge, huge political influence there. Okay, statisticians there, people who work for the government, involved in different political parties and systems and all the factions and all that. They use statistics all the time. Age demographic, okay, and then all these kinds of things. It's awesome in that sense, but not useful to learn about issues in which individuals, okay, here we're looking for population trends, population ideas. What's going on in your head really doesn't matter. Okay, so that's one of the drawbacks there for surveys and census. What do we got here? So identify the type of study being used in the following scenario. And a researcher is interested in the effects of regular exercise on patients with Parkinson's disease. So he takes a sample of 100 adults with Parkinson's who volunteered for the study and monitors the level of exercise performed and the effect it has on each patient's mobility. So, what's happening? And this is a great question. You'll see 40 of them like there after at the end of class there, okay? And again, you just read these and you pull out what's going on here. And you see here, instead of observes, they use the word monitor. And in this case here, we would call this an observational study. That's the kind of study that was involved here. Here, a clothing company wants to find out who their biggest competition is this year. Questionnaires are mailed out to all the customers from this year survey. Okay. And 2 tutoring companies claim they have the best study plan for this year's upcoming SATs. The researcher randomly assigns half of the research groups to one company and the other half to another company. The SAT scores of the 2 groups are then compared. Experimental. So that's how these work here, okay? I hope they, if I'm kind of frying your mind, right now, don't. This is week 1. You can stop this video, go back. You can go and use the book there. Make it make sense. Go over this there once or twice, and you guys will be good as gold. And if you're not, email me. We'll set up a time, and we'll have a chat. Okay. Errors. There are sampling errors, non-sampling errors. Sampling errors, error is the difference there between an observed sample statistic and an actual population parameter. So it's not a mistake, they simply represent discrepancies. So you remember there, if we want to sample an entire population and we do that, and we get an opinion about what these people are thinking, but then there was a problem there, and this particular neighborhood has a completely different opinion. Well, it's not really a mistake, it's not really an error, it's just it contradicts. And welcome to statistics. You're going to see contradictions here all the time depending on which side of the coin you're looking at. Okay? Non-sampling error is a result of an error in the study. Poor data collection. Okay? Just problems there. But a sampling error isn't really an error. It's a discrepancy. A non-sampling error is something happened there in the collection process. Types of variables. And I apologize, this, you know what I mean, what are we looking at? There's probably 50 new concepts here. But again, you don't have to memorize these, you just have to have them available there to reference. Okay? There is a lot here. You may want to organize it into, different terms and these kinds of things, but I think you guys will be all right. These are all in your book anyway. Okay? In order to calculate the value of a parameter or statistic, a researcher must first assign a variable, okay, to the attribute. Variables can be classified primarily into 2 categories. Quantity, how much? Quantitative variable, how many? Or quality, qualitative. This is something that can't really be counted. we'll get into these right here. So a quantitative variable can be measured or counted. Length, weight, time, temperature. These are all examples of what we call a continuous variable. Okay? All right? These are things there that we can measure and add and count. Okay? A continuous variable. The number of people on a bus, the number of cookies in a jar. Okay? And the number of books. Okay? So when we're talking continuous variable, these are numbers there, like you can have, like here I have a pen and a pencil. Let's say the pen is, I don't know, what's that? Let's say 12.2 centimeters long. The pencil here, let's say, is 14.4 centimeters long. You see how there's no gap. We can use decimals. There's the number from 1 to 2 can go 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2. And then you can actually go in between those numbers. You can go 1.11, 1.112. You know what I mean? And there's a million numbers in between every single number. This is what we're talking about, continuous. Okay? Today the temperature will be 25.4 degrees. Tomorrow it could be 27.9. There's no gap in the data. It just goes from 0 to infinity. All right? That's what we mean a continuous variable. A discrete variable is there is a certain number and that's it. So the number of people on a bus, there was 18. There wasn't 18.4. Okay? All right? The number of cookies in a jar. Yeah, you could have 18, but generally, you see how, yes, you can have 14 cookies in a jar, but you can also have 13 and a half after I'm done with it. So you see how right then and there, right from day one, you could start to see that generally there might be, depending on which side of the coin you're looking at, all right, the number of books on a shelf. Now you see, here is your book, by the way, right? And then I have another book here. This is a book, this is a book. But you'll see that they're not the same. Sorry, I don't know if you can, they're not, you know, this one here has 343 pages, this one here has 187. You really can't compare them in any other fashion other than them being a book. So a thin little book is the same as a big thick book. All right? So where there's actually a real number and that's it. So these are discrete. So please know there's another one. Okay? We have, sorry, where am I going here? We have quantitative variables and qualitative variables, which we'll get into. But please, it is another continuous variables and discrete. Know the difference. Okay? Qualitative variables. They can't really be measured or counted. No, you're thinking here. What does that mean? They can be classified into categories. Okay? It's also known as categorical data. So here we've got brands of jeans, color. What's your favorite color? You ask 1,000 people, what's your favorite color? Well, I like blue. He likes yellow. She likes purple. You can't compare blue and purple. All right? They just are. All right? And types of bread, genre of books, these kinds of things, if you're into horror, if you're into sci-fi or romance or all these kinds of things. So these are what we call qualitative variables. All right? Identify the following variables as quantitative or qualitative. So this is really good. I'd have a look at this one here. So here, burn classification. 1 slight, 2 moderate, 3 intense, 4 severe. Now, you can't really compare one against the other. You know what I mean? There's no mathematics involved here. So what does slight mean? That's an opinionated statement in itself. Oh, I got a slight burn. Oh, okay, does it mean I got a blister? Or I don't have a blister? Does it mean the top layer of skin has gone off? Well, where you guys are going to be all over first, second, third degree burns all over the place. So you guys will be okay on that. But the whole idea, slight, moderate, intense, severe. These are opinionated statements. Absolutely cannot compare one against the other, because what I think is intense pain, my wife would just laugh. Since she's given birth twice, she knows what real pain is. So you see, how do you compare these things? It's qualitative. The number of people who flew to Toronto Pearson Airport today. Okay? You can't have 18.5 people fly in. Okay? So this is what we call the discrete quantitative. Discrete quantitative. Discrete means there's no continuous number system like 18.4. Quantitative, I can count them. The amount of time a teacher spends marking homework. Continuous quantitative. The teacher spent 5 hours and 25 minutes. Was it 5 hours, 25 minutes, 43 seconds? We can break this down into milliseconds. That's what we call continuous quantitative. We can count it. Eye color, qualitative. Okay. And we're at the tail end. So it is a bit long there today. But it's the introduction there today, and I won't have to introduce there next week. But this is the end of the PowerPoint here. So levels of measurement. Okay. What we're talking about here, these are variables that indicate what limitations, if any, exist in how the variables can be analyzed. So there are 4 here. Okay. And I remember these as noir. N-O-I-R. It's the French word for black. All right. And N-O-I-R. Noir. Nominal, ordinal, interval, and ratio. And these all mean 4 different things. And they're not so bad. We'll go through these quickly, and then that'll be it. Levels of measurement are rules that describe the properties of numbers that are measured. So nominal. No specific order, interval between measurements are not meaningful. There's no meaningful zero. So qualitative data that is usually specified using letters, symbols, names. So here we've got gender. Okay, we can't really break this up. It is what it is. There's no number system. 1, 2, 3. You know, or we can. Some number systems there you can count by 2s. 2, 4, 6, 8. There's when you're talking gender or religion or country of birth, it's not on a scale where one is greater than the other. They're all equal. It's just data points. Okay? It's just talking about ideas and comparing them against each other. Okay? That's nominal. Ordinal is ordered by a relative position. Intervals between the measurements are not meaningful, so there's no meaningful zero. So I'll get back into this. You'll see here that there's no zero here, and for ordinal there is no zero. I'll show you what this all means when we finish all 4 of these here. And you'll have a look here. GPA. Okay, there is an ordering here. All right. Star rating. If you go to Rotten Tomatoes, and this movie here has a 3-star rating. Well, okay. 5 stars is better than 4 stars. 4 stars is better than 3. 3 is better than 2. 2 is better than 1. So if a movie gets 1 star, it's probably not very good, right? Movie gets 2 star. Okay, all right. But what's the gap between each star? Is it 2, 4, 6, 8? Is there a gap? Is there a measure? No, there's not. It's just opinion based. So here, I like that movie. I would give it 4 out of 5. That's completely opinion based. There's no mathematical measure between 1 star and 2 star, 2 star and 3 star, these kinds of things. All right? So that's what ordinal means. There's no zero, but there is kind of a hierarchy. All right? Interval. Again, there's really no 0, but there is a nice little measurable interval in between. Okay? Temperature. There is 0, all right? But there really isn't, because according to the Celsius scale, there is a 0. But remember there that I think you guys have done Kelvin. Actually, I know you guys have done Kelvin, and you guys know that there is an absolute 0, right? And just the whole thing that there is a space of 1 degree Celsius in between each one. So there is a valued measure, so we can create this scale. All right, but there isn't really a 0 or a meaningful 0. Well, I'll have examples of these all afterwards, so don't worry. And ratio. Okay, here, this is the one there that has a meaningful 0. Okay, so there is a measurable space in between. There is a scale, you know, there's a measurable space in between each one, and there is a meaningful 0. And examples of this would be percentage. I got 75% of my course. Okay, well, now you can compare that against something else. We have weight. You see, there's a kilogram in between each one. Speed is another example. Quantitative. So this is what we got ratio here. And I've got some examples here. You guys can have a look. And this is the end here. For each of the following questions, determine the type of data in terms of the level of measurement. There's your nominal, ordinal, interval, and ratio. Are you currently a student? Okay. Yes or no? What kind of question is that? Just categorical. There's no 0, there's no scale, there's no nothing. It's either yes or no. What is your field of study? Pre-health, nursing, vet tech. Again, there's no scale, there's no 0, it's nominal. What year of the program are you in? Aha, so year. Now, you see, you just go back. And where are we here? Aha, there's my interval. Okay, and what year of the program are you in? I don't like that. I'm going to change that. Thank you very much. Interval. I like that. There we go. How much tuition do you pay? You can go in there for ratio. What degree will you obtain? And have a look at these. And what I'm looking for you guys to do, make these make sense. Go back, have your definitions here, and see how these fit into here as far as being classified goes. Have a look at these, okay? And what we've got here, review questions. Which sampling method would be most appropriate for a study on passenger satisfaction for a new subway train in Toronto? And have a look at these. I put these up here. You can have a look at them. If any of them there bother you, talk to me and we can get through these. But this is it. This is, I apologize, it's long. It's the first day. Most PowerPoints won't be this long. But this is where we're at now. You guys have your questions that you guys can try there this week and get back to me. Wow, there still is people here. This is awesome. And if you guys have any questions, stick around after. Other than that, go and enjoy the rest of your week. I think today is going to be a beauty day. Make sure you get outside. I'll send an announcement out that I posted this there to YouTube. Other than that, enjoy your day. Nice to meet you. Be well, be safe, and keep in contact. Thanks, guys. Appreciate your time. I'll be around for a while after, and so if you guys, anyone want to stick around, make sure you do. No, thank you, thank you, thank you. Thank you, guys. And I'm going to stop recording right now if anyone has any questions. There we go.